All right. Hi. Can anyone hear me? Good. All right. Hello. My name is Stian. I'm from Norway, and I do web things. Like most of you people, I program front-end things in my daily work. Front-end things, data visualizations, all that sort of good stuff. But I'm also really super fascinated by language and communication. Being from Norway, I have the privilege of having English as my second language, which is kind of interesting, seeing that most of the idioms in the English language doesn't really make sense to me anymore. But it makes me aware of the role of communication and language in a different way. And the thing is that programming is communication. So what fascinates me about programming is how, even though you're trying to instruct the computer to do your bidding, what you're actually doing is leaving a trail for the people that come after you to understand what you actually wanted the computer to do. Because computers change over time, but usually the intent doesn't really change all that much. And the thing is that exploring different programming languages gives you different or more ways to communicate your intent. And that's why I like studying different kinds of computer programming languages and different ways they function so that I can communicate better with the people I work with. And that brings me to concatenative programming. Most of you work with JavaScript, so you have probably at some point been told that there is something called functional programming, programming with functions. That's a paradigm. It's a way of, it's a broadly speaking, a way of programming. Concatenative programming is another way of programming. But it's weird and strange. The thing is that concatenative languages have been around since the 70s. The 70s were a strange period in computer science. Lots of interesting things were invented in the 70s. And concatenative languages were one of them. And the first concatenative language was Forth. It was invented in the late 60s by a guy called Chuck Moore. I'm told that there actually is a place called Firth or Forth somewhere north of here. And I'm totally going to visit there after this conference. But yeah, Forth was quite widely used actually in the 70s and 80s because Forth is really lean and portable. So it was implemented on many machines. And the guy that invented it actually was carrying the whole compiler around in his briefcase, printed on punch cards. He was a bit of a character, but he got around. And then there's a language called Postscript. That's probably the language that most people have heard of, actually. Postscript is the language that powers printers, or at least used to power printers. And it's also a concatenative language. There's a language called Joy. Really nice name for a language, I think. It was invented in the late 1990s by a guy called Manfred von Thun. Really cool name. And this is where most of the theoretical foundations for concatenative languages have been made. There's a language called Factor, which is the most modern and most complete language if you ever want to try it out. There's a language called Ite, which is the language I accidentally invented. Because apparently implementing a parser and a runtime for a concatenative language was so simple that I accidentally did it. But yeah, this is what a concatenative language looks like. There isn't really a whole lot of syntax to it. There are letters and numbers and spaces. That's pretty much all there is to it. And you can do really cool things with this. But in order to understand what concatenative languages are, I'm going to try and translate it to JavaScript. This is the first step in the translation process. And here you can see that I've used the pipeline operator, which is coming to JavaScript soon. And what it does is enables you to pass the result from one function into the next function. So what this line does is it passes the result of calling the function 9 to the function suck, which is the successor function, and so on. It looks kind of strange. It's going to be looking even stranger when I do this. This is what happens if you write it with normal function calls in JavaScript. And now you can start wondering what even are numbers anymore. Because numbers in JavaScript, they don't work like that. So the language, the concatenative language is the wrong way because it's using something called postfix notation. Like the function call comes after the arguments, but the thing is, arguments aren't really arguments in here. Arguments are also functions. So the magic sauce of a concatenative language is that everything is functions. In functional programming or in JavaScript, you have the notion that a function can be a value. But in concatenative land, even values are functions. And you build programs by taking smaller functions and composing them together, or concatenating them together. That's where the name comes from, using composition. All right. It's because when you every language has values, right? But not concatenative languages, they don't have values, and that's just weird. Okay, looking back at the program, how does this even work? How do you pass values to function calls? How do you get values back? How does anything actually work? And what makes it work is that all the functions have the same signature. All the functions are functions from current state to next state. And the state is always the same kind of structure. And this means that you don't really have to be explicit about your function composition because all the signatures match up. So you can just take out all the operators and leave spaces instead because you don't need them. And the thing is that the state of your program, it's a stack. Pancake stack, nice. And every time a function is run, it can take values off the stack, and you can put the result of its calculation back on the stack. So the stack is where the state of your program lives at any given point in time. And the way this works, let's see here. Like the function 9, it doesn't take anything off the stack, so you can run it against an empty stack. And when you have run the function 9, you get a stack with the number 9 in it. And you can do this with most numbers, like this. Or you can do the successor thing. The successor function just figures out what is the next natural number after this one. And the successor to 9 is 10. So the successor function, it takes the number 9, which is on the stack. It doesn't take the number 9, which is in your code, because the number 9 in your code is actually another function. So it does this. And then you can do the whole 5. You figure out the remainder using mod, and you can check it against 0, and you get a stack containing true back. This is how you do calculations in this kind of program. But just doing this, making like a fancy calculator, isn't really interesting or fun. So one of the cool things about this kind of language is that you can take any arbitrary sub-program and name it. So I just take the sub-program consisting of 5 mod 0 and equal and name it divisible by 5. So I can just replace this sequence with the new named sequence, and I get this back. So this is how you would construct programs in a concatenative language. You just take all the large, meaningful bits and pieces of your program and give them names, and you work incrementally like that. Also, you have the stack thing. If I put 5 and 2, run the program 5 and 2, and I get 5, 2, and 5 on the stack, and if I wanted to figure out the difference between them, I could do minus like this. But if I had 2 and 5, and I wanted the difference between 5 and 2, if I did this, I would get -3. That's not really what I wanted. So you have the ability to manipulate the state of the world using special kinds of functions. For instance, the swap function, it will just swap the top two elements of your stack and lets you carry on doing what you want to do. So this is pretty much all there is to it. You can grow this kind of program quite large before it starts breaking. This example here is why I created this language in the first place. I like to do art things in the browser. So I wrote this language to help me create and explore the relationship between syntax and art. And I would love to go through this program for you, but in the interest of time, I'm not going to. But you can check it out later if you wanted to. All right, so that was like the super quick intro to concatenative languages. It's pretty much all there is to it. Like you have functions, and you compose functions, and it works on the stack. It has some really, really interesting attributes, though. Like for instance, this whole naming things and extracting subprograms and giving them new names. It makes for some really interesting and powerful optimization techniques. And also because stacks are so simple, like you can't really do much to a stack. You can only pop and read from the top of it and put things back. So many of the modern virtual machines are based on stacks. So the JVM is a stack language, CPython is a stack language, WebAssembly is a stack language. So if you wanted to get familiar with stack languages, concatenative programming is where you should be. But the most interesting thing is how has this affected my approach to programming in JavaScript? Because concatenative languages will probably never reach the mainstream. They will be relegated to some kind of obscure existence in the far corners of computer science world. But the thing is, it's not just an esoteric, strange language. It actually has some purpose to it. We know that there are languages that have been used widely in the past, and there are still people creating these languages, so apparently it has some kind of purpose. But one of the cool things when learning new languages is that you can take, you start seeing things from a different angle. So you can take that with you back to your daily work. So I'm going to look at one specific instance of where learning this kind of language has changed how I approach JavaScript. So this is the function add5. It will take any number and add 5 to it. So you can almost say that you have an add function that has had 5 partially applied to it. In JavaScript, you would do something like this. Assume that you have an add function that just adds 2 numbers. And you can use the bind operator, bind method, to attach an argument to it. And this works really nice. But when you want to build your whole program using partial application and function composition like this, you quickly start to realize that the order of your arguments matter. So if you have the same kind of function, but instead of addition you do subtraction, you want to partially apply 5 again, and you want to subtract 5 from something, this wouldn't work because you have the wrong order of arguments. If you partially apply 5 this way, you would you get a function back that subtracts something from 5. So instead you would do this. You would flip the order of the arguments, and you would get back, you would then get a function that you can actually partially apply 5 to, which is nice. So now you have a function that subtracts 5 from any number. And the cool thing is that looking at the syntax in JavaScript, this isn't something you would normally reach for unless you're told it's there. But when you have been working in a language where partial application is the most natural way to do things, you start seeing opportunities for partial application everywhere. And also, if you have some kind of function, this function looks really normal. Like in JavaScript, this would be super boring and super normal. But if you were to write this in a concatenative language, you would see that it doesn't really look that nice anymore. You have all these dupes which duplicate the top of the stack, and you get all the swaps, and like if you're trying to decipher the meaning of this, it gets really hard really fast. So what you would do instead is you would like divide this function up and give the parts of it names. So you can take the x part and you call calculate x, and take the y part and you call it calculate y. You call them with some arguments, and these are basically the same thing. And if you write this in a concatenative language, it looks really much more nicer. So when you think in terms of function composition, and especially working in a constrained environment where you only have the stack to work with, you see more opportunities for naming things. And naming things is really awesome. Like, naming things will give something, will bring something into existence. You have a concept you can talk about. You have given it some reason for being. It's nice. It gives meaning to programs. So, working in a language where naming is your own abstraction, it all programming becomes all about naming things. And usually when you program in JavaScript and other languages, modern languages that has all the things you would want to have from a language, you aren't forced to think about naming things all that often. But when you're working in a language that doesn't have any other means of abstraction, you get around to naming things more often. All right, there's even a book written about the whole process of working and naming things and all that good stuff in a book called Thinking Forth. It was released in 1984. It's actually Creative Commons license, so you can find it on the internet for free. But I prefer reading them on dead trees instead. Anyways, this wasn't really a talk to convince you to go and try and concatenate language, because like you would never get to use it. But it would be really awesome if you did. But the thing is that strange and unfamiliar languages, they offer really good opportunities for learning. And when you don't get to work with your favorite tools and techniques, like you're working in a language that doesn't have variables, you start to notice how much variables matter to you and how hard it is to program without variables. So you have to approach things differently, and you learn something new. But you come back more knowledgeable with more tools and techniques that can positively impact the way you work in your current language, which is really nice. And this is what I want you to remember from this. Like, even if you have a language that to you seems really strange, and why would anyone ever use this? Like, there's always a reason for something to be. And if you can know that reason, and if you can understand why it has become like this, and you can take that knowledge back to you and back with you and use it in your current language, it's really good. All right, that's all I had for you today. Slides and stuff you will find up on my GitHub. If you should want to explore concatenative languages, here are a few links. Thank you so much for listening.